All right, good morning, everyone. Hope your Wednesday morning is off to an exciting start. We're going to start in a new unit of class today, and we're going to focus on the skull. And this correlates, you'll have a lab on the skull as well, but it won't be for a few weeks. We're going to be a little bit asynchronous with the lecture and lab just because we have a couple labs on the muscles. And as I talked about yesterday in lab, then we'll have a week of review and then your practical. So it'll actually be your first lab back after your practical will be on the skull. So a little bit of kind of mismatch in timing here. I apologize for that. I try to arrange it so it's better aligned, but it'll be all right. So we're going to cover sections of the skull in lecture here, and then you'll be able to see all the stuff hands-on in lab. Before we get into what we're doing today for class, just a couple quick announcements. One is, don't forget, tomorrow is the OWU Connection Conference. It's all day, all kinds of cool stuff going on. I want to put a special plug in for the presentation of students from doing summer research. That is from 1 to 3 here in the Science Center. It's in the atrium. I think it's right in the atrium. Is it in the atrium? Yeah, and several of you in here, who's presenting at the poster session for SSRP? Zoe's doing cool stuff on personality in birds. So check that out. A few students from my lab are presenting on their work on lizards from here and in France, and lots of other cool research. So check that out. And there's all kinds of cool stuff going on all day. I know you probably have different assignments for different classes. I didn't set up anything explicitly for this class because I didn't, but be there tomorrow, do some cool stuff and enjoy it. Also, next week, Tuesday, we have one more lecture in our biology seminar series. This one's actually really interesting. It's about sexual conflict. And I love the name here of the organism she studies, charismatic microfauna. So this is a researcher from the Ohio State University up in Marion. And she's going to be talking about sexual selection and conflict between the sexes using these invertebrate examples here, the charismatic microfauna. So check that out. The attendance was really great at the last biology seminar series talk. I want to make sure we can keep that up. So please attend this, tell your friends. I want to make sure, especially, I know this is right before fall break, that as much as possible, we have a good turnout for our guests. All right, with that in mind, let's talk about the skull. So I've got a quick survey I want to take of the class today, just about the tutoring times. Danny asked me to check in with you. And then we're going to debrief your lab quiz from yesterday. Just want to present the overall scores. Those grades are now available in Blackboard. Then we're going to have review your muscle activity. Let me rephrase that. We have a short activity to review muscles, and then we'll get into the skull and wrap things up and some reminders at the end of class. Questions, comments, concerns? Everybody's here today. Look at this. I feel bad if there's actually somebody missing because then they were left out. 1, 2, 3, 4, 5, 6. Oh, Abby. Oh, I was just looking around. I was like, oh, don't tell Abby I said that. Abby, if you're watching this video online, I knew right away that we were missing one person. That's pretty good though. I mean, 17 out of 18. I like it. It's just nice to see everyone here. Thanks, guys. Okay, cool. So tutoring times real quick. Danny asked me to check in with you about what tutoring times on Mondays you'd prefer. He's really, really working hard to make sure the tutoring sessions work for as many people as possible. And he said he noted that there are a lot of people in the lab in the later afternoon on Mondays. So real quick, if you're going to go to a tutoring session on Monday, you can vote for both, actually, if you're likely to go to both. If neither works for you, then don't vote for either. Would you be available and interested in going to a tutoring session from 3 to 4? Just raise your hand real quick. Got 1, 2, 3, 4, no, 5, 6. Okay. And from 6 to 7, would that be better? 1, 2, 3, 4. Okay. Are there other times that work better during the day on Mondays, and specifically Mondays because you have your lab quizzes on Tuesdays? Or it's just not useful at the moment? 4 to 5 would be good. Okay, give me a how many of you would be interested in willing to do 4 to 5? You can vote more than once, remember. Not really voting, it's just 1, 2, 6. 6 for 4 to 5. Okay. Well, I'll tell Danny that earlier probably is better than, and maybe 4 to 5 would be cool. Thank you. All right, the lab quiz you took yesterday, speaking of which, the class average was an 8.1 out of 10, so an 81% You can see the distribution of grades here. 5 of you got a perfect score, so nice work on that. And you can see where all the grades fall out, kind of a uniform distribution almost, where you have more or less people, the same number of people scoring somewhere between a 5 and a 10. So just want to present that information. You can see where you're falling out. Note that class average of 81 is a lot lower than it is for lecture quizzes and exams. Yeah, but overall, it seems like the class did well on that. So any questions on that? Cool. All right. So quick review activity, 3 minutes. What you have here is a QR code for a survey that asks you to write 2 questions about muscles. So I want you to think of yourself as the instructor for this class. You're going to put together a quiz or exam on muscles. What are 2 things that you might ask? And actually writing questions is a really great way to jog your memory review. Use your notes, do whatever you want. After 3 minutes, we're going to come back and I'm going to pull up some of those questions and we're going to answer them. So it's kind of like a mini review session in preparation for your quiz. Is it not working? Oh, shoot. Okay, give me one. Oh, I didn't update the link. I know exactly what I did. Okay, give me 1 second. Sorry about that. I'm going to pause this recording so this isn't saved on YouTube. And I know you're typing on your phones here too, so if you need to use abbreviations or just, don't worry about grammars. All right, let's just give you a second to finish up. I see lots of people still typing. I'm gonna do. Is put the questions up here. I just hid your name so you can't see who wrote what. But let's go ahead and answer some of these questions. So we're gonna remind you, I have a reminder at the end of lecture, but remember you have an in-person quiz on Friday in class. So it's gonna be closed book and closed note. So this is serving as a bit of review. Remember that the quiz will cover joints. There's just one lecture on joints right before your exam, and then it will cover muscles. So I'm not reviewing joints right now. We're just gonna focus on muscles, but know that you can expect some joint questions on Friday. So let's take a look here. Give an example of a muscle named for its shape. I like that. Let's throw out some examples of muscles named after their shape. Yeah, go ahead, Holly. Trapeze. Good. What else? Go ahead, just yell it out. Deltoid, good. Sorry. Mara, just how you're in too. Spell deltoid. Give me one more. How about rectus abdominis? Remember, rectus means straight, like a rectangle. Rectus abdominis.
Transverse abdominis.
There you go. Although that the transverse. Let's break that down. What does transverse refer to in that question or in that name? Yeah. Who can help her out? What is the word transverse refer to? The direction of the muscle fibers. Good. And so transverse, does that mean that they're going kind of inferior to superior, or does that mean they're going medial to lateral? Exactly. So these are the abdominal muscles. So abdominis refers to the location. And then in that case, transverse refers to the direction of muscle. So rectus, I guess, it's both the shape and kind of the direction, and transverse are the ones that are running perpendicular to that. Now there's one more set of muscles that runs at like a 45-degree angle. What are those called? Obliques. Good. All right, let's go. I'm just clicking a random question. Oh, 4 properties of muscle cells. So you can almost guarantee there'll be a question about that. What are they, and what? Let's explain them. Who wants to do the first one? I'll just call on random people to go ahead, Veronica. Elasticity, good. And describe elasticity for us. Perfect. The muscle fibers return to their resting length after their stretch down to that. So this is, you can think of this as like the rubber band. Good. Go ahead, Mark.
Excitability.
Excitability. What does that mean?
They have the ability to conduct electrical currents to make them contract and expand.
Yeah, they receive electrical currents from neurons, and they basically follow the commands of those nerves. Good. So go ahead.
Extensibility. The ability for the muscle to be extended by outside force.
Yep, it can be extended and outside force, and what doesn't happen? Close. When you stretch it, it doesn't. Hopefully, it doesn't. Right? Yeah, exactly. You can stretch it without it. Good. Although, obviously, in extreme cases, you can't pull repair muscle, but generally speaking, they're normally used. Excellent. One more. Go ahead. Yeah, and this is why muscles are what they are. Their ability to shorten themselves. And it's really important to note that muscle fibers have the ability to shorten themselves, but they don't have the ability to lengthen themselves without accident, right? And that's a really key concept when you think about muscles, that all of the movements in our body are produced by muscles contracting. And that's why we find muscles in pairs or groups so that you can have motion in both directions. Good. Let's see. Let's look at, okay, this is an interesting one. This is really specific. I like this question. What muscle is the antagonist in the flexion of the foot? And let's be specific here and say dorsiflexion. So we're going to do this motion. What is the antagonist in that case? So in other words, what muscle is going to produce the opposite motion? Go ahead. Gastrocnemius, good, excellent. So in this case, the gastroc, when it contracts, is going to produce plantar flexion. And what's a good, just to jog your memory from lab yesterday, what muscle is a synergist with the gastrocnemius? Lies just deep to it. Soleus. Good. Excellent. I'm just looking here, what is not a property of muscle? That. 3 muscles make up the lower limb of the leg. Okay, good. That ties into more what we covered in lab yesterday. But what are 3 muscles in the distal portion of your lower limb? We just talked about 2 of them actually. This is maybe a little too easy. Yeah, you can say the tibialis anterior, and then you have the gastrocnemius soleus. We talked about the plantaris a little bit. And then there's a bunch of extensors and flexors in there that we didn't really get into detail, but there's more in there for sure. All right, who can give an example of an agonist and antagonist in a particular motion? Let's just use the example of extending your leg, so kicking. Boop. It doesn't really make that, that sound. That's awesome. Boop. What muscles are the agonists and what are the antagonists there? And these are, I'm asking this one specifically because you should know these muscles from lab yesterday. Which group of muscles is the agonist? Say again? Quadriceps, good. And what are the quadriceps? Vastus lateralis. Vastus medius, yep. Rectus femoris, and then medialis. Good. And what in this case is the antagonist? Hamstrings, which are what? 3 muscles. Semimembranosus, semitendinosus, biceps femoris. Boom. Good. Let's see here. Let me just see what other questions I'm going to ask. 4 properties of a muscle. Good. Good. 3 types of muscle. Oh, yeah. This is a good one. What are the 3 types of muscle and how do they differ? Let's break this down quickly. What's one of those types and describe its characteristics? 3 types of muscle tissue. Sarah, good. Cardiac muscle, go.
It's striated.
Good, it's striated.
And it's involuntary.
Involuntary, excellent. Second one, let's do smooth muscle. Volunteers, so good. Yeah.
It's more flexible muscle.
Mhm.
All organs.
Mhm.
It's involuntary.
Involuntary. Yeah, a lot of sphincters are composed of smooth muscle and other muscles associated with peristalsis, which is what we'll talk about when we get to the digestive system. Good. And smooth muscle is not striated. Good. And then what's the 3rd kind? This one should be skeletal muscle. Good. And we talked about that one extensively. So I think you guys have that one. Roles of muscle. We talked about that. Oh, good. Is it possible to tell a muscle origin and or insertion point just by looking at it? Why or why not? Yeah, I see lots of head shaking. No, it's not. How do we know then how do we know if it's an insertion or an origin? Say again? The movement that it produces. Good. And let's unpack that a little bit. How do we define the origin in a particular movement? It's the part that's not moving, basically. And then the insertion is going to be the attachment point that does move a given motion. Now, you'll see in lab that with lots of muscles, we generally, we kind of ascribe an insertion and origin based on the most common movement that they produce. And so sometimes we do use this term as a little bit more of a fixed thing, but in true practice, it is not fixed and can vary depending on what motion is produced. Good. I'm seeing lots of similar themes here in these questions, which is good because that means you're honing in on kind of the major ideas of this unit. Oh, let's talk about this a little bit. Let's talk about epimysium, paramysium, endomysium. So which of those surrounds the entire muscle organ and then becomes continuous with your tendons? That's epimysium, right? Remember, epi means on or above. So there you go. Which of these surrounds each fascicle? Paramysium, good. And then which of them is surrounding the muscle fibers within the fascicle? Endomysium. Good. Other questions? Anything unclear on this? March, go ahead. Totally. Let me think for 1 second. Sure. So, okay, so let's think about your hip flexors right here, right? So you have some muscles right here that are responsible for moving have their one attachment point on your hip bone and one on your femur, close to it. If I'm going to produce flexion at the waist, like this, is the insertion, or tell me, is the insertion or origin going to be on my hip bone or on my femur in this case? Femur is going to be origin, insertion is going to be hip. Now, if I do this, same muscles are involved, but now origin is pelvis and the insertion is. Yeah, sure. That's a great question. Other questions? Sweet. All right. Let's go on and talk about the skull then. Just put this back here. That's up there still. Okay, good. Still recording. All right, we're in business here. All right, your skull. So your skull is divided into two major sections, the cranium and the facial bones. So the facial bones are the anterior aspect of the skull. You can see a skull here. It's kind of pulled apart. That's basically everything up front. And then the cranium is everything in the posterior region, the big round region of your head, right? We then divide the cranium further into the cranial vault, sometimes called the calvaria, which is the big dome-like set of bones here, or the bones that form this dome-like structure. And then we have the cranial base, which is the inferior region of the skull, which is just really a couple bigger bones. So facial bones and cranial bones make up the skull. I'm going to start by talking about, actually, let me see what I talk about here. Yeah, I'm going to just talk about generally about the bones of each of those sections of the skull. So let's talk about the cranium first. The main purpose of the bones of the cranium is to enclose and protect the skull, the brain. Not surprising there. They also importantly provide attachment sites for muscles of the head and neck. So we tend to think of our skeletal muscles sometimes as being mostly associated with the limbs, and we spend most of our time in this class talking about the skeletal muscles of the limbs. But it's important to note that we have a lot of muscles in our head and neck as well. We can do all kinds of movements with our head in space, and we can also manipulate our facial structures and things like that on our head in kind of fine detail. And that's something I've talked about a little bit earlier in class about the importance of facial expressions for human evolution and communication. So two important roles of the bones of the cranium. Facial bones form your face. That's pretty important. And they also have important features that are associated with your sense organs, specifically sight, your eyes, taste, your tongue, and smell, your nose. And we'll get into this. We have a unit later in the semester on your sensory organs. So we'll talk about the kind of neurological aspects of those later in the semester. For now, we're just going to look at those bone structures that provide a site for these sensory organs to do their thing. And also, not surprisingly, your facial bones provide openings for some important things like air and food. So there's a lot of stuff going in and out of your face is the bottom line here. It's the place in your body where the most things are exiting and leaving. We have the most openings or apertures here. We've got your ears, you've got your eyes, you've got your nostrils, you've got your mouth. So all kinds of things are going in and out of our face. Finally, they also provide important site for your teeth. Your teeth are obviously very important for eating, but also play an important role in communication and speech formation. And finally, those bones anchor the muscles of your face. Now, some of the muscles of your face are interesting in that their origin is on these facial bones, but their insertion's actually on the connective tissue. So they're not actually, when they contract, they're not moving bones, but rather they're shifting your soft tissue of your face to provide facial expressions. So that's a general overview of those bones. What we're going to do is get into some detail, and we're really going to dive into the skull and talk about the specific bones of the skull here. So what I want to do first is start talking about let's start talking about the base of the skull. And if we have a transverse section of the skull, so this is a skull cut in a plane running parallel to the ground, and you're looking down on it. And so here's the posterior region, here's the anterior, right? We can divide this cranial cavity into 3 distinct fossae. So remember the term fossa, we talked about this. And your scapula, for example, has 3 fossae, etc. We have the anterior cranial fossa. That's this region up here. We then have the middle cranial fossa, which is this middle region. And see if you can guess what the last one is called. Anterior, middle, and posterior cranial fossa. Yep, nothing surprising there. The takeaway message here is these kind of flat surfaces provide support for your brain. So your brain stretches all the way across here and rests on those 3 surfaces. And I'm going to show you that from a lateral view so you can understand what that looks like. So here's a skull transected or cut in a parasagittal plane. So it's down, it's front to back, but off center a little bit. You can see the brain here, and you can see how it's resting on the anterior cranial fossa up here, just kind of superior to the eye socket, the middle cranial fossa here, and the posterior cranial fossa there. You see some parts of the brain labeled there as well. We're not going to cover that right now, but we will get into that later. But the bulk of the brain here, this is your cerebrum. This is what we probably think of if someone says brain. This is probably what comes to mind. And then your cerebellum is this little guy back here. So those are the 2 kind of largest structures of the brain. There's lots more that we'll talk about later, but I just want you to see how the cerebrum and the cerebellum sit on those fossae of the skull. Now, the skull also contains a lot of other small openings and apertures. I said there's a lot of things going in and out of your face and your skull. And there's a couple of these I want you to know. The first is the middle and inner ear cavities. So these are, not surprisingly, the passageways through which air and sound travel for your ear. We also have a nasal cavity, which is just behind your nose. Again, not surprising. That's where air is coming in and out, both for breathing and for your sense of smell. We have orbits that house the eyeballs. I'm going to show you, I'm listing these here. I'm going to show you these on a diagram on the next slide too. And then finally, we have air-filled sinuses, and these occur in several bones, especially around the nasal cavity. These are essentially these pockets within the bones where we have air and occasionally lots of mucus and things like that when we get sick. I'm going to show you what this looks like in a coronal section here in a second. So if we take a skull and we cut it along a coronal or a frontal plane, we get something that looks like this. And this allows us to see these cavities. Just a caveat here, notice this is cut anterior to the ear cavity. So we're not seeing the ears here, but you can very clearly see the orbits, the eye sockets, right? You can also see within the bones, you can see these frontal sinuses, for example. You can see, we'll talk about the ethmoid bone, but this is where there's pockets of air. We have these big sinuses right here as well, called the maxillary sinus. These often you feel pressure or you feel pain in here when you get an infection because the bacteria will hang out in there, you produce a lot of mucus. The nasal cavity, of course, is just posterior to our external nose, and so the air is flowing in and out of there. And of course, I did mention this in the previous slide, but you've got your oral cavity as well, which is not surprisingly where food and air go in. Air goes out, and once in a while, food will come out. Usually not the most fun. So that's these are some of the major structures, especially those associated with the sensory organs that I want you to know. Now, there are a zillion landmarks on the skull. I've got another cross section here that shows some of these same structures in a little more detail. You don't need to worry about the details of all of these right now. I just wanted to show this diagram, this slide, because it has an actual skull rather than a diagram, so you can see what some of these structures look like on an actual skull. And you can see the takeaway message here is you can see like these sinuses are actually these pockets in the bone that we can only see when we slice through the bone. They're not visible from the exterior because they're completely surrounded by the bone. Now, the skull, as I mentioned, is filled with these different features. In an effort to make sure this is all clear, there is a study guide available. So basically has these upcoming slides with diagrams so that you don't have to worry about copying all of that, but you can just add to it. So you can go ahead and grab that as you like. And you can just save a copy of it. It's a Google slide file. You can save a copy of this to yourself and do whatever you want with it. This is not something that I will collect or look at unless you have a question, of course. It's just for your use. So if it's useful, great. If it's not, then don't feel obliged to use it. It's completely up to you. Just a resource. I know sometimes when we have these sections where there's a lot of diagrams, the feedback I've received from students is that this kind of thing is helpful. So I gotcha. Got your back. Skull, you know. I'm trying to make that like a more of an anatomical expression, like I got your back. I don't know where that's going. Any help?
I sound like Jeffrey
Really?
A little bit.
Yeah, all right.
Skull.
Okay. That's cool. I'm gonna stop there, Marge. Thanks for the heads up. All right, then let's talk about the geography of the skull. So there's 85 different named openings in the skull, and this includes foramina, canals, fissures. We talked about that a little bit in lab. In all honesty, I'm not going to get into a ton of detail with these features in lecture. You'll see some of these in our skull lab, but I think it's a little overwhelming to cover all of these in lecture, especially without the specimens in front of us. What I'm interested in you understanding is the function of these different structures, and then we'll get into the details of the actual bones, the names of the bones of the skull here in lecture as well. Now, these openings are important for not only your sensory organs, as we talked about, and food and air, but also for your spinal cord, for example, connects to your brain inferiorly. Blood vessels, your brain uses a ton of energy, and so requires a really large blood flow. And also nerves are going in and out of your skull to the rest of your body. And so you've got openings for all of those things as well. So to show you all of this in an overwhelming way, here's a lateral aspect of the skull, and here's a whole bunch of these named processes and passageways in the skull. So for now, you don't have to know all of these, and this is on the, I think, did I include this diagram on the Google Slides that I gave you? Is that on? Okay, good. But this is a nice guide that you'll return to as we work through all of this in lecture, and then as you see this in lab. And I like this figure especially because it shows you on an actual skull. When I ask you questions in lab, I'm going to have an actual specimen of a skull or a model or a piece of it and ask you questions there. So I want to make sure you can identify these on the actual thing and not just diagrams. Go ahead, Zoe.
Super relevant. But when we're going through development, I know babies have that small part of the skull that has a hole in it. Is there a reason for that? There
is a very important reason. I have some slides to show you. So the takeaway message is that it facilitates birth, because if the bones were fully formed and fused, then the baby would have a really hard, solid head, and birth would be more painful and dangerous to both baby and mom. What that does is it allows the head to get smushed. And if you've ever seen a brand newborn within the first day of birth, they're like cone heads, and they look really alien-like because their skull literally gets smushed as they exit the birth canal. But then it evens out, and then through development, early in development, those bones completely fuse. And I'll leave it there. Hang on to that thought. I have some slides to show you exactly what that is and what it looks like. And we actually have a baby skull. It's a model in lab, and you can see what that looks like on the baby. But there's like a huge gap. And if you've ever seen a newborn too, you can see their pulse at the top of their head because those bones aren't fused. You can see the blood flow, right? It's really cool. the soft spot, they call it. Apparently, just share this with the class. Apparently, I didn't have that when I was a kid. So I have that much more respect for my mom. All right, let's talk about the calvaria, also known as the cranial vault. As I mentioned, it provides attachment sites for muscles from the head and the neck, and also importantly protects the brain. Let's break this down and talk about the bones that make up the cranium. So we've got 8 big bones composing the cranium. 4 of them are paired, meaning that there's 2 pairs. The temporal bones you have left and right, and the parietal bones you have left and right. And then we have 4 bones that are unpaired: frontal, occipital, sphenoid, and ethmoid. Sphenoid, I should say, not sphenoid. I guess sphenoid works. So those are the bones. It doesn't mean a lot in a list. I've got a slide here to show you exactly which ones they are. Maybe I'll just go to that because the same information is on the slide. So note, I have two pairs of bones, the parietal and the temporal. These are both pairs. You have a left and a right. But then you have these 4 other bones that are unpaired. You have the sphenoid, which is this kind of whack-a-mole-doodle looking bone. It looks like this kind of just vaguely rectangular shaped bone from the side, but as we'll see, it's got this really weird, unique shape internal here that you can't see from this angle. We then have our occipital bone, which is the bone on the most posterior and inferior regions of the skull. It's a big old bone, and there's a big hole in that bone called the foramen magnum, which literally translates as the big hole. That's your spinal cord enters your brain. And then we have occipital. I said those 2, occipital. Oh, the frontal and the ethmoid. Sorry. The frontal bone is this bone of your forehead, right? And goes down just to the bridge of your nose here, forms the superior aspect of your eye orbits. And then the ethmoid, you can't really see, you can see a little sliver of it here. It's a really uniquely shaped bone as well that you will be able to see. I'll show you the details of that in a second. Just want you to see where those bones are situated generally on the cranium. And everything that's in blue on this diagram, you should know for quizzes and exams. And actually, I should rephrase that. I'm talking about what's in blue here. Eventually, we'll talk about everything on this diagram. So you can come back to this diagram. All of those structures you will need to know for quizzes and exams. We'll talk about these sutures and the meatus and stuff in an upcoming section, but you have it now. So let's talk about the parietal bones. They are really big, and they form the superior and lateral parts of the skull, and their joints with other skull bones make up the largest sutures of the skull. Sutures are the name we give to the joints of the cranial bones because they're very, very tightly bound together. There's essentially no movement between these different bones of the skull. And this kind of joint we call the suture. And interestingly, you can see how it's not just a straight line, but it's kind of a zigzag, right? What that does is it serves to increase the surface area between those 2 bones and lock them into place. You can imagine that if this was just a smooth interface here between the bones, that if there were pressure on them, they could slide along each other, right? But if you have all of these kind of teeth, like almost like they're puzzle pieces fitting together, then it provides additional support under pressure and allows those bones to become even more immovable. And so you can see the parietal bone here, you can see the right parietal bone here. If we look at it from the posterior aspect, you can see you have the parietal bones come together down the middle of your head, right along here. And the interfaces, the joints with the other bones, are called the coronal suture. So you can think of this as being along the coronal plane between your parietal bones and your frontal bone. We have the squamous suture, which is here between the parietal bone and the temporal bone. That suture is there. We have the lambdoid suture, which is in the back here between the 2 parietal bones and your occipital bone. And it kind of forms the Greek letter lambda, like this. If you've ever seen the Greek letter lambda, it kind of looks like an inverted V. The capital lambda does. And so it forms that shape. So that's why we call it the lambdoid suture. And finally, the sagittal suture, which goes down the sagittal plane of your skull between the two parietal bones. So you'll notice that 2 of these 4 are named after the kind of planes that they travel along, sagittal and coronal. One of them is named for, actually, this part of your temporal bone is called the squamous part because it's big and flat. So the suture associated with that is the squamous suture. And then the lambdoid suture is named after its shape. Now, there's something else a little bit interesting that you can see on this diagram if you look carefully. Specifically, the diagram on the left that shows from the posterior view. What do you see there? Showing you the parietal bones and the occipital bone, but there's something else there. Holly.
Is what you're asking. There's like 2 little.
Yeah, there's these 2 little randos hanging out here. Kind of between, we have them colored pink here with the parietal bone, but these are not the parietal bone and they're not the occipital bone. So again, another example of how we say generally adult humans have about 206 bones in their body, but we say about because this can vary because there's something called sutural bones. And these are small bones that basically occur within the sutures and they appear early in development. Some of you probably have them, some of you don't. There's no real advantage or disadvantage to having them. It just has to do with the way these skull bones fuse early in development. And so we often find them associated with this lambdoid suture. So you can see a skull with a couple of them there. In lab, we could go and look at our skulls and you'll see some of them have these sutural bones as well. So the sutural bones we talked about, for example, the fibula, those small bones embedded in the ligaments of the knee that some people have and some people don't. This is why the number of bones can vary. Functionally, they don't seem to have any significance, though. That's the important takeaway here. Go ahead. Sesamoid?
Yeah.
Mhm.
They form like that, or are they like part of the bigger parts of the skull and they just form separately? Like, are they part of the big parts? Or are they like different parts that fuse to it?
Great question. So the sesamoid bones form within ligaments at joints, and they're restricted to only joints. So sesamoid bones in your thumb, in your big toe, your patella, the fibula bones are all associated with these joints. These guys are different, and actually these bones, we didn't really get into this in this class, but the skull bones are formed a bit differently than the long bones of the body and the bones that are associated with the joints. But what happens early in development is all of this is cartilage, and there's bony plates that form within the cartilage, and then eventually the bone grows out and it becomes solid bone, and those bones fuse together. For whatever reason, during the development, sometimes you get these little bones that develop within the cartilage, and then they end up getting fused between these ones. I don't know exactly the developmental reasons for that. So it's similar, but not exactly the same as those sesamoid bones. That's a good question. Cool. Let's talk about the frontal bone and we'll wrap things up. This is obviously an anterior view of a skull, and the frontal bone basically forms your forehead. Importantly, it contains several features that we should know. What's called the supraorbital margin. This is the superior aspect of your eye socket right here. The supraorbital foramen is this little hole through which a nerve and an artery go to your forehead. So that allows both sensory information as well as vasculature to pass through. It's a little tiny hole just directly superior to the eye socket. We have this cool feature called the glabella, which is a fun word to say. And that is this flat area just above your nose on your forehead right here. And you can feel it on yourself. It takes slightly different shape in different people. And then finally, we have frontal sinuses that are lateral to the glabella. And so they are kind of here and here. But again, remember, these sinuses are internal. I can't show you on this figure without cutting through the bone. And these guys are important because they form the base of that anterior cranial fossa that I showed you earlier. I think we'll stop there for today. I've just got a couple announcements and we'll wrap things up. What questions do you have before we do that? Just a quick show of hands to help me, give me some feedback. How many of you find the Google Slides useful for your studying and preparation? Most of the class. Okay, cool. I'm just wondering if I should continue doing that. And I will. All right, let's do this. Zip through. You guys got all that? Cool, good. All right. So, I put a comic on today's. I forgot I did that. This one's funny. Okay, so just a reminder, lecture quiz in class on Friday. It will be at the very beginning of class and will take about 20 minutes. I have not heard from anyone about taking the test in the testing center or the quiz in the testing center. If that's something you want to do, just shoot me an email, let me know, and we'll make those arrangements. No problem at all, of course. It's going to cover joints and muscles, and there's details in your class program for Friday. Reminder that Danny will have a tutoring session tomorrow, Thursday. I was going to point here, from 6 to 7 in the library. So that'll be a nice chance to review things before that quiz as well. If you have any questions as you're studying, let me know. Cool. All right. I'll see everyone on Friday morning.